Lists. In this video, we will introduce a new type of data abstraction, lists. So far in this course, we've only discussed how to assign one value to a variable at a time. In this video, we begin discussing how to assign multiple values to a variable at a time. This is done with a list variable. A list is an ordered sequence of elements starting at index 1. Here's an example of how to create a list using our pseudocode language. We start by coming up with the name we want to use for the list, which in this case is names, followed by the assignment arrow, then inside a pair of brackets, the elements that we want that list to contain. Here our list contains 5 strings: Jim, John, Alan, Kim, and Ellen. Here's another example. Here we have a list named grades, and it contains 4 numbers: 100, 75, 88, and 63. At the top of the screen is a visual of the 2 lists we just created. This visual will help us with understanding the pseudocode as we go along. Notice that in the visual for both lists, we start numbering our elements at 1. Now, if you're somebody who's programmed before, be it Java, C++, or Python, etc., you probably know that most programming languages always start numbering their lists off at 0. However, in the AP exam for AP Computer Science Principles, the pseudocode language will start numbering their list off at 1. Now, suppose I want to display one of the values in the list. That's going to require me accessing one of the values in the list directly. How would I do that? For example, suppose I want to display the first value in the names list. Well, to access that value, I would first need to write the name of the list, which in this case is names, followed by the index of the value that I want to access inside a pair of brackets. That's all I would need, and that would then give me access to the first value in the names list, which is Jim. Similarly, if I want to display the third value in the grades list, to access that value, I will need to type the name grades, followed by the number 3 inside a pair of brackets. And that would give me access to the third value in the grades list. Now, suppose I want to change one of the values in the list. For example, suppose I want to change the second value in the names list. Well, the first thing I would do is type the name of the list that I'm trying to change, followed by the index that I'm trying to change it at, which in this case is 2. And I would put that in between a pair of brackets. Then I would put the assignment arrow, followed by the value that I want assigned at that index. Here I'm asking for the value Tom to be assigned at index 2 of the names list, and that is what happens. Likewise, if I want to change the fourth value in the grades list to 100, I'll type grades, followed by 4 inside of a pair of brackets. Then on the other side of the assignment arrow, the value 100, and that would change the fourth value in the list to 100. Now, suppose instead of replacing a value, I want to insert a value inside the list at a specific location in the list. To do that, I will need the insert command. And inside the parentheses for the insert command, I'm going to need 3 pieces of information: the name of the list I'm inserting into, the index I want to insert that value at, and the value that I want inserted. Here I'm asking for the value Ashley to be inserted at index 3 of the names list. But here's the conflict. As you can see, we already have a value at index 3, and it's Alan. What's going to happen to Alan? Does it get replaced? No, it's not. What's going to happen is each value at index 3 and all the values after it are all going to move 1 spot to the right. They're going to move 1 spot over, and that's going to create space for the value that we're inserting, which in this case is Ashley. So Alan, who was originally at index 3, is now at index 4. Kim, who was originally at index 4, is now at index 5, so on and so forth. Now, suppose I want to remove a value from a list. To do that, I will need the remove command. And inside the parentheses for the remove command, I'm going to need 2 pieces of information. I'm going to need the list that I'm removing from and the index that I want removed from the list. Here we're asking to remove the value at index 2 of the names list. In other words, we want Tom removed from the names list. But here's the question. Do we accomplish that by simply making index 2 of the names list blank? No, we do not. What's going to happen is all of the values after index 2 are all going to move forward 1 spot. Now, suppose I want to add a value to a list, but I don't want to add it at a specific location. I simply want to add it to the back of the list. In that case, I would use the append method. And inside the parentheses for the append method, I will just need two pieces of information: the name of the list that I want to append to, and the value I want appended. In this case, I'm simply asking for the value 92 to be added to the back of the grades list. And that is what happens. The value 92 gets added at index 5 of the grades list. The last command we'll discuss is the length command. The length command returns the number of elements in a list. Since the names list has 5 elements in it, the length of names is 5. Thus, calling the length command on the names list will return 5, and that's the value that'll get stored inside the X variable. Iterating through a list. In an earlier lesson, we defined iterative programming as performing the same action more than once. One form of iterative programming is performing the same action on every element in the list in order starting at index 1. When we do this, we call it iterating through a list. For example, consider the following list of strings. Suppose I want to display each element in this list one by one. One way to do that would be to use the display command on each element in the list one by one. This, however, is obviously very tedious and becomes more tedious the larger the list grows. For example, suppose we had 50 elements in the list, or 500, or 500,000. In that case, we would need 500,000 display commands in order to display each element in the list. Fortunately, we have a much more concise way of doing this through the use of a for each loop. A for each loop is what we will use anytime we want to perform the same action on each element in the list one by one. The keywords for, each, and in, which are written in all caps, is what you're going to use every single time that you use a for each loop. The second underscore represents the list that we want to iterate through, which in this example is the names list. And the first underscore is the variable name we're going to use to reference each variable in the list one by one. In this case, we'll just call it n. Then, inside a pair of curly brackets is going to be the statements that we want executed on each variable in the list. Since our goal is just to display each value in the list, then inside the curly brackets, we're going to simply write display n, because our goal is simply to display each variable one by one. So, if I were to run this pseudocode on an imaginary computer, what this pseudocode would output is first the first value in the list, which is Jim, then the second value in the list, then the third value, then the fourth value, then the fifth value. Now, consider this list of numbers. Here we have a list of numbers called grades, and our goal is to curve each grade by 5, or in other words, increase each value in the list by 5. One way to do that would be to curve each value in the list one by one. But of course, like we discussed earlier, this is a tedious approach, and it would become even more tedious the larger the list becomes. A better way would be with a for each loop, where in this case, the list that we're iterating through is the grades list, and the variable we're going to use to refer to each element in the list is G. Then inside the curly brackets, we're going to simply say increase G by 5, curve it by 5. And that will then lead to each value in the list one by one getting increased by 5.